The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone, and welcome to this MassMotion webinar outlining an overview of the software and also the new proximity modeling features. Just before I launch in, we will just give people another couple of minutes just to join. I hope everyone's having a good day, whether that's at the start or conclusion of your day so far. Just while we wait for a couple of others to join, just a little bit of context. My name is Lachlan Miles, the voice that you hear. I'm MassMotion's product director, so looking after the software development team as part of Oasys. And I think the aim of today is to just go through a little bit of an overview of the software because it's new to several people, given some of the goings on around the world and some of the changes in circumstances. And so what this aims to do is give a bit of an overview of the overall presentation, as well as some of the new things that we've done to respond to the current circumstances. And so with that said, I think we may as well jump right in. And so overall, why are we here? Why are we dialing in? MassMotion is a software package developed by Oasys that allows users to design spaces for people, essentially, and it allows people to understand the impacts of pedestrian flow and crowd flow within the designs and operations of their space. And that sounds quite nebulous, I think, to some people, but effectively what it allows users to do is to interrogate designs from a human perspective, from a user experience perspective, and from a capacity perspective, and kind of really quantify some of the impacts on the people movement aspects of your design. And that could range from anything from if you have a transportation environment where this kind of tool originates and has a long history on how we can design better and more efficient transportation interchanges, or airports that can balance user experience with efficient movement of people and staffing needs, through to if you're looking at large-scale cultural events or things that require movement of people, how you can do that in a safe and effective way and really prioritize the user experience as part of that. And so it's a very broad tool. It can be used basically anywhere that there's a crowd, effectively. And so what this will do is give a bit of an overview on what constitutes a MassMotion model, a little bit of the history, but then going through and spending the majority of the time talking about how this tool, which understands the way that people move, has been adapted and upgraded to help solve particular operational challenges that most of the world finds ourselves in at the moment with the COVID-19 pandemic. And rather than looking at a space for how can we maximize throughput, how can we design or retrofit some of the operations within our spaces to understand how we can do this in a physically distant way, and a way in which we can balance safety from a social distancing perspective with clean and efficient design. So what does it actually look like? This is a very brief video just showing the breadth of different environments. And so we see that you can effectively use this to understand a range of design and operational challenges across a number of different sectors in the architecture, engineering, and construction industries, ranging from either major public gatherings with tens or hundreds of thousands of people, through to more intimate and detailed studies of things like a museum lobby or the entrance experience for a high-rise building. And so effectively, the thing that brings all of these different designs together is an understanding that movement and flow of people is something that should be as clear as possible and as efficient as possible. And this is a really complex thing to design because you have a lot of different moving parts. You have people with different motivations, people move at different speeds, all of those things. And MassMotion allows you to take some of the guesswork out of dealing with that and layer in as much or as little operational complexity as possible. And so why does this tool exist is a question that sometimes gets asked, in terms of, where did this come from, and what's the background, and how did we end up with a very flexible human movement simulation engine, especially if you're not from a traditional engineering background where this kind of study has occurred for a long time. And I think when we're solving these sorts of movement challenges, this has been going on. This is a field of academic research for several decades. And in terms of simulation and understanding of these spaces, it's been going on for decades as well. So MassMotion fits within that historical timeline, but also has existed for the last 10 or so years from a position of innovation and a position of how we kind of partly change the way in which this design happens to make sure that it happens in a more data-driven way and in a more flexible and user-focused way. And so effectively, MassMotion was developed to solve complex transportation challenges. So looking at how you can quickly move people through, say, a major transportation interchange or a major aviation interchange in particular environments where you had new complex spaces, you had a significant understanding of where people were coming from and going to. So the numbers of people getting off your trains, for example, or the load factors on your aircraft, but not a particularly detailed sense of how people would actually move within those environments. And so existing tools were very, at the time, assumptions driven. So a user of the tools would have to effectively step people through, this is how many people would walk up this particular escalator, this is how many people would walk through this particular stair, these are the people who will walk to the left side, these are the people who will walk to the right. And that those tools allow a great, it's also, you're testing not so much the design, but you're testing the assumptions of the person using it. And it was a time consuming and quite manual process. And so effectively, the aim of MassMotion was to try and strip out as much of that as possible, make sure that it was based on a sound foundation, and make sure that we were delivering a tool that happens in a more BIM native environment where you're taking advantage of technology as it improves. And so really trying to take out some of those manual interventions so that you can more rapidly test different designs and different operational parameters. And we see that that is obviously something that is coming in handy at the moment in a very topical sense. And so I think it's just important for people who are new to this field of human movement and are new to understanding what MassMotion is, that this isn't a tool that was created in the last 2 or 3 weeks to solve a COVID-19 challenge. It is a piece of software that has been developed over a long period of time and had features added over a long period of time based on a significant technical and research background. And I'm happy to answer questions at the conclusion of this presentation about any of those things. And so just really briefly jumping in, based on a bunch of academic research going back to the 1960s and 70s about human movement and the science of human movement, but then customized based on real world projects. And so the aim of that is to develop a tool set that encourages the user to have some flexibility around people movement, but also understanding how people actually use this software, in that you might not be an expert in the human movement field and you just want to have the confidence to say, I have an origin and I want to have 50 people move across my complex space from X to Y. And so MassMotion has a series of algorithms that will take into account both the short-term decisions, so walking, taking in charge of your neighbors, things like that, based on a lot of academic research that's been developed over the last several decades, but also at a longer-term network sense. So should I take the stairs or the escalator? Should I, walk through this corridor or another one? And so that is all basically handled by the software itself. In terms of the evidence base for this, we calibrate the software to a bunch of industry standards. One of those is the Fruin standard, which governs, based on some first principles research, the relationship between speed, density, and flow rate. And we also calibrate to a bunch of standards around emergency egress. So MassMotion is used a lot in normal operation scenarios, so how to design or operate your facility in a more efficient way. But it is also used from the fire engineering community for how can I egress and evacuate this space in a safe and efficient way. And that's a field in which making sure that what you're doing is repeatable and evidence-based is clearly critically important, because we're talking about fire and life safety, and it's something that we take incredibly seriously as Oasys. So that's a little bit on the technical basis, and again, happy to go into a little bit more detail. Overall, when we're talking about how does this actually work, we've talked about a little bit of what the basis is and a little bit about the history, but what is the actual workflow and how does someone actually use this tool? Currently, MassMotion is a desktop-based tool in which you will import a space in which you want to test. Commonly, this will be working with either 2D or 3D data. MassMotion is able to import this data. You can create your own, but most people deal with, say, existing design workflows. So if you have a model of your existing space or your proposed design, and you're doing that in, say, Revit or Rhino or SketchUp in the 3D world, or in AutoCAD, for example, if we're looking at 2D CAD plans, MassMotion will enable you to import that and then start to define things. These are my areas of walkable surfaces. These are my obstacles to flow, those sorts of things. And you're basically defining the space in which people will populate. The second step is really about populating that space. So how many people do I have here? At what rate are they arriving? Things like that. This can range from very, very simple origin destinations. I want 30 people walking around my theme park, starting at the entrance and finishing back at the same entrance. And that can be done quite in a straightforward manner. You can also do very complex operational space. So what happens if I'm walking into, say, walking around an art gallery and I need to check my bag, check my coat, go and get a ticket, move through various different galleries, pause at various points, and layering on all of that operational complexity is something that can be done within the software itself. And so the movement is handed off by the algorithms within MassMotion. The giving people a shopping list of tasks to do can be orchestrated by the user. And there's no upset limit. There's no we don't gate the number of people that we can have within a MassMotion simulation. It can range from dozens of people moving around a fairly small space through to studies of the Hajj with several 100,000 people moving through a very complex space at quite high densities. And so it's a very flexible tool set from both an operations and from a scale perspective. And then really the meat of MassMotion, I think, beyond the simulation engine, is really about how do you get value out of these simulations? How do you understand what the impacts are of either different design decisions or different operational paradigms? That could be staffing, it could be different ways in which you assign queuing, those sorts of things. And so MassMotion has built within the software a robust series of tools, and we're going to go through some of the new analyses from a proximity perspective shortly. And so just very, very briefly, this is what the MassMotion user interface looks like. It's a native 3D application, so users will interact with this as they would, something like Revit or Rhino or SketchUp, import geometry, set up your rules, and if we take a look at the kind of the top ribbon there, we see we have scene, activities, and simulation. This maps quite clearly to what I was talking about a little bit earlier, in that these are the key steps of a MassMotion project and the key components of the software. Building a world, populating that world, and then analyzing that world are the three key components of a MassMotion simulation. Now, talking a little bit more about outputs and talking a little bit more about value, it's not just, hey, here's some images of some small avatars, virtual pedestrians moving around. It's the ability to pull out a bunch of metrics, and analytics is critical to when we're talking about this as a design tool or as a way to understand people and to quantify the differences between various designs. And so there's a range of graphs, maps, and tables that can be extracted from the software and then either passed on to further post-processing, such as exporting CSVs for Excel or exporting visual graphs or maps of a space. What we have here is looking at a density map to quickly highlight hotspots for congestion and ways in which we can say, if we have design A and design B, here is the actual difference in terms of congestion between those two designs, or here's the impact if we make this design change. And it allows you to quantify an area that is commonly hard to quantify, I would imagine. And then you can also do things like export a range of videos and images to communicate what's going on in MassMotion. And there's also a MassMotion viewer, which allows you to take your simulation run or a portion of such and then share it with clients or customers. So where has this been used, or where have clients and customers used MassMotion in the past? It's a fairly broad list, and I'm not going to go and list various different projects off, but effectively moving from its genesis in the linear infrastructure world, looking at airports and major rail stations across the world, it has since been used on a range of major art galleries and museums, major stadia, looking at public spaces from an events perspective, looking at schools, looking at various different other things. I mean, it was used at one point by a customer looking at movement across an ice rink as part of a public event. And so it's quite a flexible piece of software, and we are working very hard. And I'm going to talk a little bit at the end of this presentation about some of the work that we're doing to help propel this in a more flexible way. And so if that's not enough, there are ways in which we can interact with the software beyond just using the software and just layering on all of the various complexity or stripping it out, as the case may be. If you need to either test different ways in which agents behave in a very non-standard environment, or if you are interested in automating aspects of this process in either setting up or running various models, MassMotion has a full-fledged software development kit that allows you to basically automate or extend elements of this using code. And so I think this is why several people have tuned in, and so all that is to say, that is what MassMotion does now, but what have we done over the last number of weeks in order to extend these analyses and extend these different behaviors in order to understand the way that people move through space in a socially distanced world that we find ourselves in. And so just off the top, MassMotion is a calibrated and validated way to understand people movement. We are not a software that allows you to look at virus transmissions. So really this is about what are the impacts of social distancing adherence rates, how will my space perform if I make queuing adjustments or things like that. MassMotion, from my perspective as product director, is used for how will this space operate in our new normal, rather than how many people will get sick if this happens. And so it's a useful scenario testing tool when we're talking about either returning to work, reopening facilities, how do we get people back on public transportation, those sorts of things. And so we've made it easier for people to ask these sorts of questions specifically over the last couple of weeks, and this is all available right now. And so these are ways, and I'll run through these quite quickly, different ways in which we can visualize people within proximity, within a user set proximity. So in the example here of a small train station, everyone who is more than 2 meters apart is in blue, and then dynamically we can show people who are closer than 2 meters in red. There are different ways in which we've added new maps to understand time within proximity. So understanding not just what is the overall density of my space or where are my hotspots from a crowding perspective, but really looking at where are the places in which I have the highest intensity of people waiting within 2 meters. And that allows you to potentially target interventions within your space. And then finally, we've accelerated some of our work into new simulation types and new research into human movement to give users new abilities to say a portion of this population will socially distance given the room effectively. So try and maintain 2 meters of personal space in certain environments in a broadly realistic way. But it for low density environments, which I think most people are testing in, is reasonably sound and gives people the flexibility to test those various different scenarios. So what does this actually look like? And I'll run through a couple of quick examples before diving into a little bit more detail. And so if we look at, say, queuing environments or more controlled environments, MassMotion can allow you to understand the impacts on not just how can I set up my space in order to reduce time within 2 meters or 1 meter, depending on your jurisdiction or your health department, but also what are the flow-on effects of that? What are the flow-on effects from a space planning perspective? How much more space do I need for queuing? By how much is my throughput reduced if I can only have 1 in every 2 staff members working, checking things in an airport? And this is the kind of thing that when we're looking, particularly in the aviation environment, everything's okay at the moment because you might only have 5% of demand. But as we see things start to progressively move back up, we try and understand what is the effective, where are the tipping points and where are there going to have to be additional interventions made. And so similarly, in a kind of an arts and culture environment, if we're thinking about how can we reopen some of these facilities and really give the users or designers of that space comfort that things can be done in a socially distanced way, what is the impact of, say, establishing a one-way queuing system and enforcing, if you enforce different ways of movement and different queuing operations, what does this do, A, to your time within proximity, but B, what does it also do to the amount of people that you can hold within your facility, which has obvious impacts on things like how economically viable is your art gallery if you can only exist at 15% capacity? How viable is your theme park reopening if you have to institute a whole bunch of really significant operational layers, those sorts of things? And so how do we do this, and how can we quantify some of these different things? And so there are two key components, which I'll go into a little bit more detail about, and they are the proximity filter and proximity maps. The proximity filter leverages MassMotion's existing analytical framework, which allows you to really quickly drill down into a subset of the population and look at, I want to know the overall trip time, not just of everyone in my models, but from all of the people who started at a particular place, all of the people who may have, gone to this particular concession stand, the people who might be interacting between certain subsets of the population, so people from different areas or people with different speeds or those sorts of things. The kind of emergent behaviors that are very hard to do in a spreadsheet or just thinking about how different populations might interact. The current MassMotion analytical system allows you to really drill down into those subsets of the population. We've added a proximity filter to basically say, you can do all of that, but only look at this when you are trying to understand the number of people within 1.5 meters or the number of people within 2 meters that are affected by this. And it allows you a great deal of flexibility to try and understand some of those things and to quantify the impact of some different scenarios. We've also produced a series of proximity maps, and I'll go through those in a second, but different ways in which you can quite visually compare different scenarios from a before and after case, or also from a what is the impact of various interventions. And so the first one of these is a time and proximity map. And what this effectively does is lets you specify a certain distance. In this case, this is a rail station looking at time within 2 meters and time thresholds. So quickly mapping your space after you've run a simulation to say, where are the hotspots where people spend more than 5 minutes within 2 meters? So where are the areas of my space rather than numbers of my people where I have either the highest risk or the greatest opportunity for interventions? And so what we see here is, with keeping the population consistent, what happens if you institute a one-way system to reduce cross flows along a platform environment? And so on the top, we have a business as usual where you have a lot of free flow movement and things like that. So all the areas in red are where people are spending more than 5 minutes cumulatively within 2 meters. The one on the bottom is what happens if you basically institute one of these one-way systems. So the staircase in the center of the platform is, from memory, one-way down, and the escalator and stair combination is one-way up. And so this really gets to the heart of what MassMotion is historically used for and how it is used in different ways. And that's to really quickly be able to make either a design or process intervention and understand what the impacts of that are. So rather than having to go right back to the drawing board and saying, hey, what happens if one of these stairs is one way, or what happens if I need construction hoarding around one of these areas, you can basically add that in, quickly resimulate the model, run significantly faster than real time for anything up to several 100,000 people, and quickly assess in a quantitative way what is the impact of that and what is the difference if I make these changes. And so particularly when we're thinking about things in the COVID-19 world, it's about as regulations change, as business requirements change, is trying to understand what are the impacts of these various different scenarios and being able to rapidly test them before we deploy them as pilot studies in the real world. Secondly, we've added a maximum proximity map, and this is a quick way in order to understand hotspots where you might have significant crowding. And this comes with a combination of potential safety concerns, but also it's where you're concentrating your risk. And so the example here is looking at a commercial lobby where the entrance to the elevator cores is where you have the largest density of people. And maybe this might be where you want to target your additional queuing or limiting the population in certain areas and things like that. Finally, we see an instantaneous proximity map. And what this allows is really, instead of looking at the individuals and having them kind of change color within their kind of 2 or 1 or whatever meter radius, this is an understanding of the overlaps of where certain people are. And so this can give the ability to really quickly and in a compelling way understand some of the different areas within your space that are at high risk, and then also how that changes over time. So being able to export a video where you see people moving around, and then where those kind of hotspots do change over time is quite compelling to assess these risks. And then just going into slightly more detail about the proximity filter, but beyond just changing the agent color, it also lets you understand various different things. So is the time in my queue, specifically when I'm lining up for a particular process, when I'm within 2 meters, if I make this intervention, I can reduce that time specifically by a given percentage, 30 or 40%, those sorts of things. And being able to quickly and effectively communicate the impact of targeted interventions, we think is quite powerful. Now, finally, one of the key things and one of the biggest lifts from the development team's perspective is when we're talking about things in a socially distanced world, and when we're talking about things where people's behavior is different. And I'm sure everyone who's on this call right now or listening to this webinar has been in a public space where there is an increased hesitance on behalf of the population and desire for at least a subset of the population to try and maintain, at least in general circulation, greater interpersonal distance than before. And so what we've done is we've enabled users within the agent's profile in the same way that you can set, this particular population or subset of the population we'll be looking at. You might have data on aged populations and they move at a proportionally lower speed, or you might be looking at different populations who might have different agent radius and size implications. What we have enabled is a personal space parameter to say, all things considered, if I have the space, here's how far I would like to spend away from other people. And so we will find these agents being able to slow down, to kind of veer out of the way in a slightly more directed way than regular movement in order to maintain that distance. And so rather than just set that as a constant value, because we realize that one of the key things is what happens if not 100% of the population adheres to this, and what happens if, say, a particular government entity decides to change, say, from a 2 meter specification down to the World Health Organization's preferred 1 meter guidance. What is the impact of that? And so you can basically set either a distribution of different personal space parameters that each individual across the population will adhere to, or say, 30% of my population will strictly socially distance. And so that's an input to these models, and it allows you to basically use that as another thing to test. This is based on the existing, this is based on changes to the social forces model. And that's basically giving people a parameter to change an element of this. And we've been able to do this because one of the major things that we've been going through as a development team is how do we take the latest research into the real state of the art in human movement, and how do we bring that within the software, and that's being able to provide a more flexible tool set to our users, being able to do things like interact with new data types. And so that's a current long-term development process, and we've invested heavily in academic partnerships in order to do that. And one element of that has been how we can target certain elements of the social forces algorithm in order to make that user exposed. And so we view this as kind of one step in an overall journey to make MassMotion more flexible, and for people to be able to bring in different customizations for things like demographics, for things like family groups, for things like different ways of movement in different parts of the world, or different space typologies. And that's an ongoing area of really exciting research and really exciting software development. And so one portion of that is available now for all users. And so finally, when we're talking about COVID-19 return to work or return to facilities, there's also a much heavier influence or heavier focus on queuing and direct operational processes. So I'm sure lots of people have seen either vinyl decals on the ground, people have seen different queuing environments. We've upgraded the server object within MassMotion in order to have the ability to tweak various different parameters around that personal space setting. And so that could be either setting a constant spacing as previous MassMotion users were able to do, or to be able to say, take the maximum of the preferred spacing within here and individuals' personal space preferences. And so what does that look like when you put it all together? It allows you to quickly spin up a simulation. So if you have, say, in this case, a 3D model of an office lobby, a quick way to baseline things: what happens if I have a certain number of guests who have to check in? If I have a number of elevators, how many elevators allow me to quickly express people through? And then in a COVID-19 kind of world where you want to do things like make additional checks on the number of people. So if there's a formal queuing process, what is the throughput of my lobby reduced to? And we see in this particular case, we can reduce the time in proximity by 64%, but the overall throughput and the efficiency of the lobby has been reduced by 46%. And then if we were to zoom forward and take a look at, if I can only allow 2 people in my elevators at any one time, what the increase in queue time, for example, is in an elevator. And then if we look at some of those maps, it could be, here's the overall hotspots in which I need to look at. Do I need to reduce another turnstile? Are there some extra architectural interventions that I could make on a temporary basis in order to understand things? And so finally, I thought I'd just give a little bit more context around not just where the software has come from or where it is now, but also where the software is going. And so the proximity modeling features are released right now, and they're available for all of our users. But the work is never done, and there's a really exciting package of works that we are going through over the coming months and years. And that includes things like additional changes to avatars to bring in greater representation, so male, female, scalable height, all of those sorts of things. And then the ability to take fly-through camera paths, so to be able to have more compelling communication, and also to bring in additional ways in which we can automate and script things in a really easy way, kind of bringing some of the MassMotion software development kit within the core software. And then, as I've talked about before, one of the key things that we're doing is a fundamental re-look and re-investigation of the behavioral engine, taking into account some of the latest research, things like cloud enabling works to make sure that we can run larger and larger models with millions of agents significantly faster than real time. And then also a bunch of different changes to behaviors, so how we better take into account things like different demographics and things like groups and stuff like that. So there's a lot going on, and it's an exciting time for MassMotion, and we're excited to continue on this journey for the world's most flexible pedestrian simulation software. So I'm going to leave it there. Thank you all for your time, and hope you all have a lovely day.